We are given this figure, two identical circles plus a large circle right here. Each of these little circles have an area of 1 unit squared. With that information, seeing where the tangency lines are drawn, what is the area of the big circle? Pause this video, see if you can solve it, and let me know what the answer is in the comment section below. But as always, we're gonna dive in and solve this problem, or a way to do it. I'm gonna connect a line from the center of A, B, and C in that circle. So we have A, B, C, let's go connect a line here. One across. We have A, B, and C are all on a straight line. Now I'm gonna do something a little different. I'm gonna connect the center of C and the center of B to this bottom line that's tangent at circle B and C at a 90-degree angle. So at the point of tangency, it actually creates, as you can see here, it's gonna be like a 90-degree angle right on, and this one too. So we have a 90-degree angle there. I'm gonna connect it at that spot at the point of tangency, because tangent to a circle theorem states at a point where a circle has a tangent line at the end that's connected to the radius, right? We have a right angle that occurs. That's tangent to a circle theorem. So we have a nice right angle right here, and another one right there. Let's call these points D at the intersection and E right there. Now I want to add some more labels here. A and B, those two circles, have the same, well, radius, right? If they have the same area, they have the same radius. And so let's go label that little r. So BE, little r, that's the radius of that circle. The big circle, let's label that big R. Kind of easy to figure out here. So we have little r and big R, okay? Now, I also noticed one thing about our figure now. We have two triangles that were drawn here. We have triangle ABE and triangle ACD. We know they both have a right angle right here, and we know that both of them share the same angle CAD or CAE. That angle, let's call that alpha. So they both have angle alpha and a right angle in each one. Well, if that's alpha, and we know that that angle right here and the other angle have to be complementary angles, let's call this one beta. The same thing occurs here. We have beta right there. And these triangles all have the same, well, angle measurements on the inside, meaning that they are similar triangles. And we know that similar triangles have proportionate side lengths. But we only know big R and little r. What about these side lengths? What can we get with them? Well, notice here that this side length of triangle ABE, the top one here, the hypotenuse, has a side length of little r plus a little r, or 2r. So AB, that length is 2r. The radius, the small circle, right there. What about side length AC? Well, side length AC has our big R, our big radius, right? Plus little r, little r, little r. 3 little r's are plus 3r. And now we actually have enough in terms to set up a proportion. Let's start with our small triangle. This leg is r over the hypotenuse 2r. And that is equal to the leg, big R, over the other hypotenuse, R plus 3R. Now R over 2R can simplify to be a 1/2. We cancel the R's here. So we have 1/2 equals R over R plus 3R. Cross multiply here. 1 times R plus 3R is an R plus 3R, little r. 2 times R is a 2R. Let's get our big R's to the right. All these R's minus a big R. And 3R equals 2R minus 1R, which is just one big R. So now we know that 3 little radiuses equal 1 big radius. So let's go back to our small circles. The area of our small circle is pi little r squared, and we know that's equal to 1. Our large circle here, I'll use L instead of B because I already used B here. But the area of the large circle is the same formula, pi, but big R squared. But what do we know about big R? Big R is equal to 3 little r's. So the area of the large circle is pi times 3 little r's squared. Simplify that out. Area of the large circle equals pi. 3 squared is a 9 times an r squared. Move the 9 to the front. Area of the large circle is 9 times pi r squared. And well, pi little r squared is equal to 1. So we have 9 times a 1 here, and the area of the, not the big L, but it is the large circle or big circle, is just 9 units squared. And after all of that, a pretty easy answer, it's always nice when it's nice and simple, is 9 units squared for the area of the big circle. I hope you got that answer, but if you did it and learned something, that is awesome. And as always here, thanks for watching.